Hello everyone, myself Sravanthi, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today our topic is phases of compiler with example. So, what are the examples we are going to see to compile a source program into the machine language? So, there are 6 phases which we have discussed. So, we are going to take one example from the source program, that is nothing but we are going to take one example that is as a source program, nothing but high level language, and we are going to generate in each phase what it generates, and it gives back to the next phase, and finally it generates the assembly code. So let us see the examples. So the first example is, this is the source program, nothing but this is the high level language which is given as a input to the lexical analyzer. So the lexical analyzer, what it generates tokens. The lexical analyzer generates tokens. Tokens are nothing but identifiers, constants, operators, all those will be there. So let us write the lexical analyzer phase for this. Position, it is nothing but some identifier id1 equal to, operators are same. Next, initial, it is identifier id2 plus it is a operator, trait is nothing but identifier, and 60, it is nothing but some values are nothing but constant 60. Okay, so this is nothing but the lexical analyzer phase. So this is given as a input to the syntax analyzer phase. So nothing but it generates tokens, and these tokens are given as an input to the syntax analyzer. Okay, the syntax analyzer, what it does, it generates parse tree. So let us write here what are the phases. Lexical analyzer. The next we have syntax analyzer. The next we have semantic analyzer. And the next we have intermediate code generator. Next we have code optimizer. And the next we have code generator. So this is nothing but it gives us high level language or source program. Lexical analyzer generates tokens. These tokens are given to the syntax analyzer. Syntax analyzer generates parse tree. The parse tree is given as an input to the semantic analyzer. The semantic analyzer generates annotated parse tree. These annotated modified parse tree is given as an input to the intermediate code generator. It generates 3 address code. Nothing but abstract language. That is given as an input to the code optimizer. The code optimizer, what it does, it removes or it optimizes the code. Unnecessary data, all those are removed, and it is given to the code generator. So these are the 6 phases we are going to apply for this example. So the first given, it is a source program. It is given as an input to the lexical analyzer. The lexical analyzer generates tokens. This is nothing but the lexical analyzer. These tokens are given as an input to the syntax analyzer. The syntax analyzer, what it generates, what is the output of syntax analyzer? Parse tree. Nothing but it checks any errors are there, whether it is able to generate a parse tree using the context-free grammar or regular expressions. Any ambiguity is there, all those are checked for the tokens. So what I am going to have, the parse tree we are going to generate here. So equal to operator, the left I have is id1, and the next here I have, what is the operation I am going to do here? Multiplication is having the highest priority, id3 into 60. And the next what I have here, id3 into 60 plus id2 plus id2. So this is nothing but what phase it is? Syntax analyzer phase. It is the syntax analyzer phase. This is given as the input to the semantic analyzer. The semantic analyzer checks any errors are there, semantically it is correct or not. Nothing but any blocks are there or any type conversions are there, all those are checked here. See here, rate is nothing but some value that may be float value. So float into integer is nothing but we are going to get the output as float. So that is the reason we are going to convert this 60 into float. So what we are going to write equal to int id1 as it is. The next I have plus, next id2, next multiplication and id3. So what we are going to convert it into flow, into constant value, nothing but integer value we are going to convert. So what I can write into to real. We can write into to real or else into to float. Into to float. We can write into to real or into to float. So what I am going to write 60. This is phase is what? Semantic analyzer. This is syntax analyzer. This is the semantic analyzer. This is given as an input to which one? Intermediate code generator. So what it does, intermediate code generator, it generates 3 address code. It generates 3 address code. So what I am going to do, from down we are going for the top. So 60, it is in float value. So I am going to write here T1 is equal to into to real. Which one I am going to convert into to real? 60 I have converted into to real. The next what I am going to do, this is I multiplied with id3. So I am taking temporary variable t2. What I am having here? id3 into 60. id3 into 60. But 60 is stored where? In t1. So I can write it as t1. We will write it as T1. Why? Because it is already stored in T1. So this part is completed. So the next what I am having, ID to T3 is equal to ID2 plus, where it is all stored in T2. This whole is stored in T2. ID2 plus T2. Now next. So ID1. The next. This whole is stored where? In T3. So now that we are going to assign. ID1 is equal to whole is there in T3. So this is nothing but the 3 address code. This is given as input to the code optimizer. So the code optimizer, what it does? It optimizes the code which is generated from 3 address code. See here, T1 equal to into to real and T2 equal to ID3 into T1. Instead of writing T1 directly, I can write this statement here to reduce the code, to optimize the code. See here, T1 is equal to ID3 into to real. Into to real. Yes, we can write it into to real. The next statement, this statement is reduced. The T1 is gone. So the next T2 is equal to what I am going to have? ID2 plus T1. This whole is stored in T1. This is there in T1. So T2 equal to ID2 plus T1. So the next I can write it as ID1 is equal to T2. From 4 lines of code, I have reduced it to 3 lines. Or else we can also reduce these to 2 lines also. Instead of this statement, I can write it as x equal to ID2 plus T1. X equal to ID2 plus T1. So with these also 2 lines of code, it is going to be reduced. So this is nothing but code optimizer. This is the code optimizer. This is given as an input to the code generator. So the code generator generates registers. The code generator generates registers. So let us write this one here, code generator. The code generator, what we are going to have here, first in the code generators, we are going to have move, load, store, all these, the registers we are going to use to store the registers. So here what I am having, first I am going from here. So move float value. So I am going to move the float value 60.0 into R1. Okay, I am going to move this 60.0 to R1. So nothing but the value 60.0 is stored in R1. That is the meaning. So the next what I am having here, multiply float value. Why? Because mul is multiply, f is nothing but float value. Here we are going to have float value. ID3 comma what I am having here, R1. So it multiplies ID3 into 60 and it stores in R1. It stores in R1. So this is completed. So the next what I am having here, move float ID2 comma R2. ID2 I'm moving to register R2. R2 register I move. So the next what type of operation I have here? Add float value. So what I'm having here? R2 comma R1, or else I can write R1 comma R2, doesn't change. So here R2 comma R1 is nothing but the value it adds, R1 plus R2 it adds, and it stores the result in R1. Here it calculates or it adds R1 plus R2 and it stores the result in R2. So it adds, and then what I'm going to do? The whole result is assigned to ID1. So move float value. So where I am having here result in R1 I am having. So to which one I need to move? R1 comma what is the thing? ID1. The whole result is moved to ID1. So these are the 6 phases to compile. These are the 6 phases of a compiler. When we have a expression, when we have a source program, so these 6 phases will be done to generate the assembly code. Okay, so this is a one example. Same thing here. We have written lexical analyzer 60 and it generates intermediate code it generates, and it is given to here, and it generates the code generator as this one. So it generates the code generator. So these are the things we are going to do here. So the next one we are having is, next example is I equal to I into 50 plus j plus 3. I into 50 plus j plus 3. The same thing, the same 6 phases we are going to generate. So first we are going to convert it into lexical analyzer. So lexical analyzer is nothing but we are going to write it in the form of identifiers. So I is nothing but ID1 is equal, same I is there, ID1 into 50. 50 is a constant value, plus j is nothing but ID2 plus 3. ID2 plus 3. So 3 and 50 are the constant values. So this is nothing but lexical analyzer. This is nothing but lexical analyzer. This is given as an input to the syntax analyzer. The syntax analyzer, what it does? It generates a parse tree, whether it is by using the context-free grammar. Okay, it checks the regular expression. It generates regular expression, and by using that regular expression, we are going to construct a parse tree, syntax tree. So equal to ID1, I here multiplication ID1 into 50 plus ID2 plus 3. ID2 plus 3. So ID1 into 50 plus ID2 plus 3. So this is nothing but syntax analyzer. This syntax analyzer is given to the semantic analyzer. The semantic analyzer checks any errors are there. If any errors are there or any type conversions are there, that is done. Here I and j are, initially I have declared in I and j are int I comma j. But if it is converted into float, so nothing but the output we are going to get it as a float value. So that is the reason we are going to worst scenario we are going to check, and we are going to convert it into float. So equal to ID1 plus, so 3 is nothing but what I am going to write? We are going to convert it into float, into to float. Anything doesn't change, float. The next plus ID2, next multiplication, next ID1, and here 50. 50 is also we are going to convert it into float, into to real or into to float, doesn't change. Same, both are same. So this is given as a input to the syntax semantic analyzer. The semantic analyzer converts it into float. Type conversions are done. So this is nothing but semantic analyzer, and it is given as a input to the intermediate code generator. So now the intermediate code generator generates the 3 address code. So move what I am having float value. So 50 move into to real 50. Okay, so we are going to do here same thing what we have done here. So the same thing is done here. So next what I am going to do here, move into to real 50 we have done, which we have done here 62.02 R1 here, sorry, where I am having into to real. So the same thing we are going to convert here. So we are going to generate the 3 address code. We are going to generate the 3 address code is nothing but temporary variables are used. Int to real. So int to real. Int to real of 50. The 50 is stored in T1. The next what I have T2. T2 is equal to ID1 into, it is stored in T1. It is stored in T1. The next, this whole is stored in T2. This whole is stored in T2. Now it is allocated to T3. T3 is equal to T2 plus ID2. So this is there in T3. T3. Next T4 is equal to T3. T4 is equal to, we'll write this one also, int to float 3. So the next T5 is equal to T3 plus T4. The whole thing is there in T4. Now that is T5. This is assigned to ID1. So ID1 is equal to T5. ID1 is equal to T5. So this is nothing but 3 address code. These 3 address code is given to the code optimizer. So the code optimizer optimizes the code. So what it does? So instead of these 2 statements, directly I write IT1 equal to ID1 into to real of 50. ID1 equal to these 2 statements I merged and I have written a single statement. Why? Because in order to optimize the code. So the next one is T2 is equal to T1 plus ID2. Next T3 is equal to what we can write here, T2 plus into 2 float of 3. And next T4 is equal to, so what I can write, T4 is equal to is nothing but T4 is equal, the whole thing is there, T2 plus T3, and it is stored. I can directly write here this statement, ID1. So how I have written these 2 statements, instead of writing T1, directly I am writing into to real, and I stored in T1. So with the help of this, one statement got reduced. The next T2 is equal to T1 plus ID2. The T1, this is not there, so it is stored in T1 plus ID2. So next what I am having, the whole thing till here it is done. So the next what I am having here, this whole is there in T2. This is there in T2. T2 plus what I am having here, into 2 float 3. Into 2 float and 3. So that I am going to assign it to ID1. That we are going to assign it to ID1. See here. This is nothing but T1. It is done. And this is T2. And next T3. So directly I can assign here ID1 equal to T3. Instead of writing that statement, directly we can assign it to T3. So this is nothing but code optimizer. This code optimizer is given to a code generator. So the code generator generates the output. So what it does here, initially I have into to real. So I can write move float. What I am going to do, 50.0 to R1. This is moved to register R1. The next what I have here, multiplication, float value, ID1 comma R1. ID1 into R1 it does, and it stores in R1. The next what I have here, add float value. So the result is having in R1 ID1 comma R2. We'll write here ID2 comma R2. So this statement we can write, or else we can also write this statement as this one. So what I can write here, move float value ID2 comma R2, and next I can add R1 comma R2. We can add. So first what I am doing, I am moving this to register R2, and then next this whole thing is stored in R1 and R2 it does, and it stores the result in R2. So the next what I am having here, move float value 3.0 to R3. We are going to move this one into R3. The next what I have here, add float value. The whole thing is stored in where? R2, comma, R3. It adds R2. This is nothing but R2 and this is stored in R3. R2 plus R3 and it stores the result in R3. It stores the result in R3. So again I am writing here, add R2 comma R3. Add R2 comma R3. It adds and then what I am going to do, the result is stored in R3. That it adds R2 and R3 and it stores the result in R3. And then what I am going to do, we are going to assign it to ID1. So what I am going to do, move float value R3 comma ID1. This R3 value is assigned to ID1. So this is nothing but code generator. So it generates registers, nothing but machine understandable language. So the target code is generated here. So these are the two examples of a phases of compiler. So first we need to generate the tokens. The tokens is given as an input to the parse tree. The parse tree is given as an input to the semantic analyzer. The semantic analyzer checks if any errors are there. If it is fine, then it gives it to the intermediate code generator. If I find any semantically errors, here we have integers. So we are going to convert it into float and then we are giving as an input to the intermediate code generator. The intermediate code generator generates integers, nothing but temporary variables. 3 address code is generated here. These 3 address code is given as an input to the code optimizer. The code optimizer generates it optimizes the code which came from the intermediate code generator. Then we are going to generate the finally, that is nothing but the target code, machine code, assembly language code. So nothing but with the help of the registers, we are going to generate the code generator. So these are the 6 phases of a compiler. If while compiling any phase, if we get any errors, all those are rectified using the error handler. All these identify as tokens or values or the scope of these all are stored in the symbol table. All are stored in the symbol table. So when a source program is given to compile, to generate the machine language, so these are the internally these 6 phases are going to be take place to generate the output. So this is about the phases of the compiler, examples of phases of compiler. In the next coming class, we will discuss about language processing system. Thank you.